Today we shall study the method of false position to solve algebraic or transcendental equation f of x equal to 0. So in this method, we choose the points x0 and x1 so that f of x0 function values at point x0 and x1, they are of opposite side. So exactly as in the bisection method, here we choose the points x0 and x1 such that the function values at these points are of opposite side. Now, if we why this condition we impose here in this method? So as the function values at points x0 and x1 are of opposite signs, the graph of the function f of x equal to 0 that crosses the x-axis. Just a minute. So that crosses graph of the function f of x crosses the x-axis between the 2 points x0 and x1. And that is why we impose this condition to find the solution of the equation f of x equal to 0. And as the graph of this function f of x crosses or intersects x-axis between the 2 points, then we claim that the function f of x equal to 0 has a root which lies between 2 points x0 and x1. So just you can look at the graph which I have here. See the graph. See. So what we have here? This function. So this function, this curve, is the graph of the function, this one. This is the graph of the function f of x. And we have chosen 2 points x0 here and x1 here, so that the value of f of x0 is positive here in this graph, because this point A lies in the first quadrant, and the value of f at point x1, that is f of x1, this is negative because this point is in the fourth quadrant. And we know that in the fourth quadrant, this value is y coordinate is negative, and in the first quadrant, here y coordinate is positive, right? And therefore, the function we have the function f of x which intersects or crosses the x-axis at this point, and therefore we call this point as the root of the given equation f of x equal to 0, right? So we have here 2 points A and B, and what is the idea? We join these 2 points A and B, and here you can see that this intersects x-axis, touches the x-axis. So this is the straight line. We call this straight line as a chord. So this is a chord to this curve, right? And we know, so chord is a straight line, or I can say that this is the equation of a line. Yes, this is the line which passes through 2 points, capital A and capital B. And we know how to write the equation of a line which intersects x-axis, right? This. So that equation of a line can be written in this way. Again, we go back to here. So what is the geometrical construction here? we join the 2 points, which gives a chord as shown in figure. So we have these 2 points. So how do you write the equation of that straight line which passes through the given points? So that is nothing but this. If we know 1 point, we can have this y minus y0 divided by x minus x0. But what is y0? Y0 is nothing but f of x0 that I have written here, and this x0. Okay. So y minus y0 divided by x minus x0 is equal to, this is what? Y1 minus y0 divided by x1 minus x0. So this number, whatever, because x0, x0, x1 is known, x1, y1 is known, and therefore you can have a slope. So this right hand side, this is called the slope of the straight line which passes through a given 1 point, right? So the equation of a chord is this one, is written in star equation star. So this is the equation of chord, right, which touches the x-axis. Now, what we do, we replace this curve with this straight line which passes through the points x0, f of x0, and x1, f of x1 by joining the chord in 2 points. So we replace now, see here, I will go to figure now, see that. Now you can solve that and get this next fact. See here. So we have point like this, x0, x1, and we can determine point x2. So the point x2 is written like this, is here, which is the point of intersection of a straight line or chord joining the 2 points A and capital B, right? We will get this point. Mathematically, how to get this, I will explain that part. But before that, I will give you the idea how this method works further. Okay. So we initially we have 2 points x0 and x1, right? By as the values of f of x0 and f of x1 are of opposite signs, right? And we join these 2 points, you will get a curve, and that chord intersects x-axis at some point. We denote that point as x. So this is the first step. Now we have 2 points. In all 3 points, x0, x2, and x1. Now, to proceed on the same line, we have to see that in which part the root of the given equation lies. So I have first part x0 to x2, right? I have another part x2 to x1. And again, you check that condition, hypothesis. F of x0 and f of x2, and then f of x1. Again, you choose the point, you choose the subinterval so that the value of function values are of opposite sign. Now here, see, what is the value of function value at x2? So here, what are the coordinates of this point? x2 comma f of x2, right? Again, this point lies in third quadrant, so y coordinate is negative. So not third, fourth quadrant, right? So we have here this value is negative, this value is negative. Yeah, f of x. I am writing only the sign for the function value, right? And at this point the value is positive because f at x0 is positive, which lies in the first quadrant. So what is our claim? Root of the given equation, next approximate root of the given equation lies in which part? This part. From x0 to x2 and not in this part, because the value of function values at x2 and x1 are not of opposite sign. Both values are negative, right? And therefore we neglect this interval, right? So in the next step, new solution interval is this, from x0 to x2, right? Then again join the new points A and this point. You will get a chord. Find the equation of that chord, right? And solving that equation, you will get a new point, which is x3. X3 point, right? Okay. Again, you find the value of function value at which point? X3, and see that that value is, you will get new point. Again, that value is negative because that lies in the fourth quadrant. Again, this original interval x0 to x2 is divided into two parts. So one is x0 to x3 and x3 to x2. Again, check the condition. Function values to have a solution interval, the function values must be of opposite signs. And see here in this part, which I have here, in this part, the function values f at x3 and f at x2 both are of same sign, not of opposite sign. Both values are negative, and therefore the solution or root lies between the interval x0 to x3 in the first part, I can say, right? So again, you join these points, you will get new point x1, which is the intersection of this straight line chord and x-axis, right? So proceeding in this way, you will observe that you are very close to the root of the given equation. So like this. So this is the root, the exact root of the given equation, because this curve, this graph of the function intersects x-axis at this point. So here see, in the method, in the first step we are here, then in the next step we are here, so that the exact root is very closer and closer if you perform more and more steps, right? So this is the working rule or way of applying the method, Regula Falsi method. Now mathematically, how do you get this? So that we will discuss. Okay, so this is the graphical interpretation of this Regula Falsi method. Okay, so whatever we have here in mind graphically, we put it in mathematical way. Okay, so see here how to get this, how to get point x2, x3, right? So we have this equation of straight line star, right? So what we do here, we substitute equation star. In equation star, we substitute this value y as 0, y minus f of x0 divided by x minus x0. Here we put value of y as 0 because, what is the reason? Because that coordinate where, or the point of intersection, you have a point of intersection where we see that the value of y is 0, because on x-axis the y coordinate of that point is always 0. That means we have y is equal to 0. So in this expression, what we do, we put y is equal to 0 and see what we have. Here we put this is 0 and simplify further, right? Its simplification is done below. So let us quickly go through it. See. So what we are doing, we are putting y is equal to 0 here in star. So if you put y is equal to 0 in the numerator of left hand side of equation star, we have y minus f of x0. So y is 0. So 0 minus f of x0 in the numerator. Rest of the things remains same, right? And then we find the value of x. To find the value of x, what we do, we simplify in this way. See, just you multiply and divide. So here the calculation is like this. So this is 1 minus 1 upon x minus x0, or x minus x0 is in the denominator in the left hand side. So if you shift it to the right hand side, what we have here, x minus x0 in the right hand side. Okay, and here in this expression, first expression, it is here. So this, if you want to write in the left hand side, what we do here, take the reciprocal of this. So reciprocal will be x1 minus x0 divided by f of x1 minus f of x0, and this quantity remains as it is. Okay, so this is as it is, I have written. Okay, and this is the reciprocal, this, but written in different way. This is the reciprocal of this quantity, x1 minus x0 divided by f of x1 minus f of x0. And as we have to find the value of x, what we do, we just add x0 on both sides, and that gives this one, x equal to x0 minus f at x0 divided by f of x1 minus f of x0 multiplied by x1 minus x0, right? So what is x1 minus x0? Mathematically, it is difference of 2 points, right? And geometrically, it is the length of that subinterval where the root of the equation x. Okay, so to find, so this formula, this is called Regula Falsi method, and this formula gives you a next approximation. So here we denote x by x2. So x2 will be x0 minus f of x0 divided by f of x1 minus f of x0, x1 minus x0. This is the value of x2. So write x2 in this way. X2 is this. Yes. First equation, number one equation. Now, so this first step is over. First step of Regula Falsi method is over. Now, due to x2 point, your original interval gets divided into two parts. Just we have seen it in figure, right? X2 is x2 lies between x0 and x1, right? And now check whether in which part function values are of opposite sign. We have to see. So there are two possibilities. Either the function values in x0 and x2, or the function values f of x2 and f of x0 are of opposite sign, or the function values f of x2 and f of x1 are of opposite sign. So either of one possibility is there. So we assume that f of x2 and f of x0 are of opposite sign. Then what we claim? The root lies between point x2 and x0 and x2. And we replace, in this case, we replace point x1 by x2 in equation 1, and that gives the next approximation as x3, right? But if reverse is the situation, it means if the function values f of x2 and f of x1 are of opposite sign, then we have to replace x0 by x1, right? And there to get next approximation. And here, after replacing x0 by x2 in this equation 1, we get next approximate value as this. X3 is equal to, see, formula is same, just we are changing the point. So here we have to change x1, right? X1, change x1 to x2. If this is there, if the root lies between x0 and x2. If root lies between x2 and x1, you have to change x0 by x, right? So that the formula will change, and this is the value of x3. See, x3 is equal to x0 minus f of x0 divided by f of x2 minus f of x0 into x2 minus f0. So again here the x2 minus x0 is the length of that sub-interval. So we have to repeat this procedure till we get the root as per your desire, so that you'll get the accuracy of the approximate root to the exact solution. And graphically, the method is shown below that has been already discussed. So this is all about the Regula Falsi method. So why we call this as Regula Falsi method? Because the root of this equation is here actually, which where the curve, this function cuts or intersects x-axis, crosses x-axis. So that is the exact root here. See, here at this point, this is the exact root, but you are here initially f2 then f. So first position is there, and hence the method is known as Regula Falsi method. Now let us quickly go to the problem. See here how to apply this Regula Falsi method to solve to find the root of the given equation.